What's up everyone, Nitish this side. I hope you all are doing really well. And in this video, I'll be sharing with you guys one of the best method in order to solve any recursion problem, right? So we have two types of recursion. Basically, the first one is a linear type of recursion and the second one is divide and conquer, right? So by the means of this video, I'll be introducing you to one of the very amazing method or very helpful method which we call as Akra-Baazi method, which is used to solve the time complexities of divide and conquer recurrence relation. Now, what are the prerequisites to watch this video? Let's look at this. So the number one prerequisite is basically that you should have a basic understanding of recursion and time complexity. That's it. Recursion, basic understanding of recursion and time complexity. So for all the viewers who are watching me from a good time back, you might ask me this, where is the laptop screen for now? So it's not there, but I have this thing. I'm seeing just, yeah, it's working fine. So I'm basically will try to explain you what is this method which we call as Akra-Baazi, what is the type of the form, how to solve the time complexities as well, and we'll also look at some questions as well. Okay, just let me see if I can find some other thing. I just wrote some other thing as well. Just let me try to see it. Okay, sorry for that. Now remember, there are actually two types of recursion. Let's see. So yeah, I just have to do this. Okay, so there are two types of recursion. Okay, there are two types of recursion. So the number one type, basically two types, is linear and second is divide. Okay, what is this linear? Linear is basically of Fibonacci series. Fibonacci, right? Remember when we used to do something like this, Fibonacci of nth number is equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. This is the thing. Got it? This is for the Fibonacci or the linear. What is it? Divide and conquer. Divide and conquer basically has the form something like, basically we have here binary search. Do you know how do we use what is the form of the binary search while solving the approach using the divide and conquer? So basically the form is something like this. We have an array of size, say it like n, we'll divide it into half with constant time complexity, space complexity, sorry. For example, let me try to explain you. For example, this is your array. This is your array. And what you do, in order to search it, you divide it into half, then again divide it into half, then again divide it into half, things like that. So a constant space complexity, and we are dividing the array into half. That's it. But now, what is the time complexity? What is the time complexity of binary search? You tell me, what is the time complexity of binary search? The time complexity of binary search is big O of log n. Correct? Now, but how do we calculate the time complexity of binary search using basically how do we calculate the binary search time complexity of binary search? This is the question to us. Okay, so for all those people, what happens is in your BTech semester there is a theorem which we call as Master's theorem, which you guys can use, but there are some limitations to Master's theorem as well. So I'll be, first of all, if you are using Master's theorem, okay, if you are using Master's theorem, I have two questions for you. Just try to solve this. Okay, wait, yeah. So just try to solve this question using Master's theorem. Time period of n equal to 3t into n by 5 plus 2t into n by 5 plus theta of n. And the second one is time period of n equal to, sorry, not time period of n, whatever I'm saying, n by 3 plus theta of 1 by n. For all the students who are actually using Master's theorem, right, just try to solve the same using these two questions using the Master's theorem. You won't be able to. So Nitish, does this mean that if I'm not able to solve this Master's theorem, these questions cannot be solved? No, the questions can be solved with the help of Akra-Baazi method. It's simple. Okay, and Akra-Baazi method is basically for divide and conquer. Divide and conquer. I'm just saying it's recording well. Yeah. divide and conquer method. Got it? Okay. Now, as mentioned, divide and conquer basically has the binary search. Binary search means we have an array of size n, we divide it into half again, n by 2, we again divide into half, n by 4, and so on, things like that. Correct? And you tell me, what is the time complexity of binary search? Big of log n. Let's try to find it. Just remember this relation. What is the relation for this? F of n equal to f of n by 2 plus this one, constant space complexity. This is constant. Got it? Now understand this, important things are going to come here. Okay, now see what is going to happen now. Suppose we have the relation as f of n equal to f of n by 2 plus constant space. Correct? We are going to use the Akra-Baazi method now, and we also look at some of the equations as well, right? The questions which you have seen earlier, I'm going to solve those questions as well for you. Okay, let's see what is the form of divide and conquer. What is the form of divide and conquer? Okay, what is the form of divide and conquer? Okay, the form is something like this: time complexity of x equal to a1t into b1x plus some function x, okay, plus a2t into b2x plus some function x up to so on ant into bnx plus some function x plus gx. This is very important, plus gx. This is a form. Nitish, OMG, this is so like we have to learn every single thing. No, just learn this stuff, this stuff and this stuff, and just remember this. You have to basically add this new things. So what I want to say is like this: we have something like this, I equal to 1 to n, where ai t of bi x plus basically this is the form, correct, plus g of x. This is the form. This is the form of divide and conquer. Again writing you, let's see, time complexity of any function x equal to a1t into b1x plus some function x up to so on ant into bnx plus some function x and plus g of x. Now Nitish, you said that this is a form of the binary search, then this means that this form is applicable here as well, this to binary search as well. Sorry, this is a form of the divide and conquer. This form is actually applicable to binary search as well. Let's see how we can relate this form to the binary search. Okay, just let me see. Sounds good. Okay, so we have the binary search, something like this: f of n equal to f of n by 2 plus constant space. This lecture might be little bit lengthy, but please understand this is going to be very helpful for you. Okay, and what is the form we have? We have is a1t into b1x plus some function x up to so on ant into bnx plus some function x plus g of x. This is the form. Let's try to relate here. Got it? So f of n is t of x. Got it? Okay. What is a1 here? a1 is equal to 1 because it is 1 into f of n by 2. What is b1 here? b1 equal to 1 by 2. What is some function x? Some function, I'm not saying sum. I mean sum. Some function means any function x, things like that. Okay. So what is the sum function x? Equal to 0. Okay, got it. And as you know that this is basically this constant space complexity, then this basically means that it's constant, or we can also write it something like c. This is a constant, so we can write it g of x equal to something like c. Constant. Got it? Let's try to solve this. Now the Akra-Baazi method is going to come here. Now is the Akra-Baazi method. Okay, Nitish, we have got to understanding this is the form. This is not the Akra-Baazi method. Now the Akra-Baazi method has come when we are going to solve this, when we're going to find the time complexity of divide and conquer relation. Let's see Akra-Baazi method now. whenever you have this form, this one of a divide and conquer, remember Akra-Baazi method will come and solve your time complexity like this. It will help you to find the time complexity like this very simply. So let's see what is the formula. What is the formula to find the time? What you have to learn? This thing. What you have to learn? Formula. These two simple things you have to learn. Nothing else than that, and you are going to find time complexities really very well. Got it? Let's see. What is the formula for? So T of x equal to theta, or I can say any big O. I can also say as big O, but let's say theta into x raised to power p plus x raised to power p integral 1 to x gu, like here gx is c, it means gu is c, constant, okay, upon u to the power p plus 1 into du. That's it. This looked so scary. What is this? Don't please don't get scared. This is the only thing that you have to learn. Nidish, what is this p? Let's try to find p as well. So p is basically something like this: a1 into b1 to the power p plus a2 into b to the power p up to an into bn to the power p. This power p is to the b. Okay, this power p is to b equal to 1. So basically I can write something like this: sigma I equal to 1 to n, where ai bi to the power p equal to 1. This is the p. Simple. What do you have to learn? This thing. Three things you have to learn. Three things. What are these three things? What is the form of divide and conquer? What is the formula of Akra-Baazi method? And what is this p? That's it. It basically not three things, two things only, because this is actually the one thing you have to learn: the formula and the form. Formula and form. That's it. Let's try to find now the time complexity of this with the help of this formula. So let me just see what are these things. So we have let me try to write it again. Okay, f of n equal to f of n by 2 plus big of 1. Got it? We have as a1 equal to 1, b1 equal to 1 by 2. Okay, then this some function x equal to 0, and we have g of x is constant c. Okay, what is the basically the formula? T of x equal to theta into x raised to power p plus x raised to power p integral 1 to x gu upon u to the power p plus 1 du. That's it. Okay, this is the thing. Let's try to solve this now. So T of x equal to theta. But first of all we need to find p. So let's try to find p now. So 1 into 1 by 2 to the power p equal to 1. What should be the value of p? Let's try for p equal to 0. Let's see if p equal to 0 is valid. So 1 into 1 by, and anything to the power 0 is equal to 1. So it basically 1 into 1 by 2 to the power 0. Does this term give 1? Does this term give 1? Let's see. So anything to the power 0 is equal to 1. So 1 into 1 equal to 1. Yeah, p is 0. Okay, this is the thing. P is basically, as mentioned earlier, p is what? a1 into b1 to the power p plus a2 into b to the power p, and so on up to an to the bn to the power p equal to 1. The sum should give me 1. Okay, and here we will have to find the value of p. So here I found that value of p is 0. Got it? Sounds good. What is the next step? We have got the value of p as 0. Okay, so T of x equal to theta into x raised to power 0. What is x raised to power 0? Anything to the power 0 is 1 plus x raised to power 0 1 integral 1 to x. What is this gu? What is this gu? Gu is gx or gu is equal to constant, c constant. So basically, okay, c constant, this is a constant, and upon u to the power p plus 1. What is this p? p0, so it means u, okay, and du. That's it. Theta into 1 plus 1. Basically this c will come outside of the integration because this is a constant. C log u and 1x, that's it, equal to theta into 1 plus c log u minus log 1. What is log 1? Log 1 is 0. So it is equal to theta into 1 plus c log u. Now you know, understand this, you know constants are ignored and less dominating terms are ignored. Less dominating term. What is the less dominating term here? This one, constant as well ignored. This is also ignored because this is a constant. Okay, so what is your answer? Final output, theta of log u. Sorry, log x. Sorry, log x. Answer. That's it. Using Akra-Baazi formula. Got it? So let's try to find some other question as well. Okay. Let's see if it's recording well. Yeah, sounds good. Okay. Remember when I give this question, t of n equal to 3t of n by 5 plus 2t of n by 5 plus theta of n. Got it. How are we going to solve this now? You tell me, is this constant? Is this constant? No, this is not constant. Okay, this is not constant because it contains the term n. Got it? Let's see. Okay, you tell me. Let's try to write the. Do we have to write the form here as well? Okay, let's try to write the form here as well. Okay, t of x equal to a1t into b1x plus some function x plus a to t into b to x plus some function x up to so on up to a n t into b n x plus some function x plus g of x. Got it? What is a1 here? What is a1 here? 3. What is b1 here? 1 by 5. And this thing, what is this thing? a2 equal to 2, b2 equal to 1 by 5, a2 equal to 2, b2 equal to 1 by 5. This 1 by 5, 1 into n equal to 1. Got it? And what is this? Some function x equal to 0 and some function under x equal to 0. Got it? And what is this gx? This is basically we can say it as x, or we can say it as, let's say it like gu. So it's basically u. Okay, g of x or g or u, whatever you want to say, it's u. Got it? Let's try to now, what is the formula for Akra-Baazi? So time of complexity of x equal to theta into x raised to power p plus x raised to power p integral 1 to p gu upon u to the power p plus 1 du. This is how you are writing so fast. Trust me, I'm not an expert in this. It's just a practice. Okay, only thing that it takes is to have a good practice of all this stuff. Got it? Let's try to find the value of p. So 3 into 1 by 5 to the power p plus 2 into 1 by 5 to the power p should give me 1. Okay. Now what should be the value of p? What is the value of p? Should be something like, let's see if I try to find the value of, let's try for p equal to 0. So it basically it will be equal to 3 plus 2 equal to 5, which is not equal to 1. It means p equal to 0 is not your answer. P can't be 0. Let's try for p equal to 1. Let's try for p equal to 1. Okay, let's try for p equal to 1. 3 into 1 by 5, 3 by 5 plus 2 by 5, yeah, 5 by 5 equal to 1. It means it is giving 1. It means the value of p is correct here. So p equal to 1 is my answer. I got the value of p as well. Okay, let's go ahead, and time complexity of x equal to theta into x raised to power p. What is p? 1 plus x raised to power p. P is 1. Integral 1 to x. What is gu or u? It is u by d. Upon u to the power p plus 1. What is the value of p? The value of p is 1. So u square into du. That's it. Simple thing. It's recording well. Yeah, it's recording well. Got it. Theta into x plus x. So this u cancel. So it basically x log u theta equal to x plus x log u, and it's 1x theta into x plus x of log x minus log 1. What is log 1? 0. So theta of x plus x log x, x log x. Is there any constant? Is there any constant? No. Is there any less dominating term? Yes, this is a less dominating term. Ignore it. So your final answer is x log x. Naresh, why are you not ignoring this? This is not a constant. X is not a constant here, okay? So your final answer is x log x. Answer. Sounds good. And similarly, we have another question as well. Make sure you go behind and try to solve that question, second question, by yourself, and comment down the answer. What is the time complexity you got of that divide and conquer relation. Akra-Baazi method is not for every type of time complexity form you see. There are actually two types of recursion: linear recursion, divide and conquer. Akra-Baazi method is used to solve the time complexity of only divide and conquer. Okay, don't try to solve it using the Fibonaccian. There's another method for that. Okay, don't try to solve for that. Okay, this sounds good. And basically I have one more thing to introduce here, and that is there are actually two things that we can introduce here, but I will introduce you to that particular thing regarding the P stuff. So ignore what I said. Basically what I want to say, this video is getting a little bit longer, so what I want to say you guys is that there are actually two things as well that we have to see. First thing is, what if we can't find the value of P? Can't find P. What is the thing that we have to do? And second thing is basically how to find the P. So this is the first thing, and this is the second thing, how to find the value of P. You have also got an understanding, right, of what is the formula for calculating P, but still I'm emphasizing on this, how to find the P. Sometimes you want to be able to find the value of P. So what to do in that case? You have to do something to find the value of P in order to solve the question. So what's the thing that we have to do? Basically this video, this portion will be covered in the next video. Okay, I don't know when you are watching this, but whenever you are watching this, I can bet you one thing, this part shall be covered by now, soon, very soon. Okay, make sure you go through the other videos of my channel as well. I have done some amazing podcast sessions. I have also taught some of the lectures regarding the Golang, regarding the open source contributions, and yeah, I mean, like, good stuff is there on my channel. You can definitely explore that channel, and feel free to connect with me on Twitter. All the links for the social media platform has been given in the description. Stay tuned to this channel, and I'll see you guys in the next video. Bye bye, take care.